Okay, so let's start off a new blank Touchdesigner. So just File, New, and let's get started. So the first thing I'm going to create is, if I look at our reference again, is I'm going to create a background of some description that is 3D, and it has a bunch of points in space that we can set colors to randomly. So this thing here, and then in my example, if I play it, it's also scrolling up. But we can get a bit more creative than that when we're developing it out. It's just an idea of what we're going to do. So the first thing we need to create is the 3D world. So we're going to make some sort of shape that is in 3D. We're going to make a camera that's looking at it, and then allow us to see the output of that camera's view. So I'm going to come up to this top bar and split my pane layout into three. So I'm going to have one big one on the left and two on the right. I'm going to drag the middle bar over slightly. Now I'm going to go up to my top right panel, and this little triangle in its top left corner called Pane Type, I'm going to change that to Geometry View. And if you've ever used a 3D program before, this window works the same. So I can hold left mouse and rotate. I can hold middle mouse and dolly in and out, or I can hold right mouse and I can pan. And if it goes wrong and you lose everything, you can do right click, home all, and that'll reset you to looking at the 000 point. In the bottom right one, I'm going to open it, and then I'm going to go to panel. And this will just be black for now, but what the panel viewer is doing is it's showing us the rendered output of this container here. Now I said we weren't going to talk about containers much, but all we need to know is a container holds code, and it can also showcase one outputted piece of content. So in the case of buttons or sliders, it shows the background of that button. And in the case of this window, it's going to show the whole output as the camera is seeing it. So I'm going to scroll back into that panel. So I'm inside project one. I have my geometry viewer on the right and my panel viewer in the bottom right. Now, anywhere in your window, double click, and we're going to start by making a box. So I'm going to make a box SOP. So I'm going to go to the SOPs tab, find a box, and place that down. Now, a box by default doesn't appear in our geometry viewer, even though it is 3D. All SOPs by default exist in a 3D world, but they don't exist in Touchdesigner's global 3D world. To do that, we need to put a shape into something called a geometry. So I'm going to right click my box, and I'm going to add a null SOP to the chain, because it's always good to have nulls to terminate our chain so I know where it stops. And then I'm going to double click and place a geometry comp. So I'm going to go to the comp tab, geometry, and place it. In our window on the right, we'll see that we've got this big donut, or a torus has appeared, which is the default geometry, and it's green. And it's green because I've got the geometry, or the Geo1, selected. If I click off of it, you can see it no longer is green. But this torus, or the donut, is not our box. So I need to go inside the geometry, and I'm going to delete whatever's there, which should be torus 1. And I'm going to double click and place a in SOP. So I'm going to go to the SOP from tab and place an in. Now, with that done, it means when we place an in or an out, it means that we can pull content over different levels. Again, too much of container talk, but I just need to know what's happening. So now if I scroll out of the geometry, we can see it has a blue little inlet that it didn't have before. If I add a blank one again, we can see it has no inlet, but it shows a torus. We just deleted the torus and added something called an insop that allows me to connect my box into this environment. Our box still doesn't show in our world because we need to tell Touchdesigner that this is the specific one we want to see. So to do that, all of my SOPs have 4 little dots next to that Activate Viewer panel we talked about in the first video. And this allows me to say, okay, I want to display it. And the purple one next to it says I want to render it. Now, render is what our camera is going to do in the final stage, but display just means that we can see it in this 3D world. So blue means we can see it, purple means that our camera will be able to see it eventually as well. And now, if I activate this geometry viewer, or look in the top right geometry viewer, using the same controls, I can now see a cube and rotate around it. So we're half of the way there. We've made a 3D shape, and now we need to add a camera to it. The camera system inside Touchdesigner requires a few parts, but they're always the same for every 3D build we'll ever do after this. So I'm going to double click a blank space on my network, and I'm going to add a camera. I'm then going to double click again and add a light, both from the comp menu. And then I'm going to double click and I'm going to go to the top menu and I'm going to look for a render. And a good way to remember this is we need a camera and a light so that we can see our scene and that we can add light to it. And then we need a render because we want to turn it back into a 2D scene. So render, remember, is a texture, and a texture is always 2D. So now I have my 3D cube visualized from a 2D perspective. And if I zoom my scene in 3D far enough out, we can actually see my camera at the top here, looking down onto my cube. So that's my camera. My light is even further away, out here at 10. But my light and my camera now look at my cube along this Z-axis, and it gives us this output here. Okay, we now want to take our render output and place it into our panel, so that at all times we have our 3D scene on our window and a version of what our camera's seeing also on our window, just for reference for us to use. So I'm going to right click the output of my render, and it'll give me the network tab, or the operator dialog tab, and I'm going to select null. And all that does is it automatically does the work of connecting it for me. I could quite as easily have double clicked, added a null, and connected it myself. But now that I have null, I'm going to double click its name bar where it says null2, and I'm going to call this output view. So this is almost me setting it to have a variable name. I'm then going to scroll up one level, look at my project container, and in its look tab, you can see I can set something called this background top. And we know tops are textures. So I'm going to type // that says go inside of your own container and get what we just made called output view. And if you type the name of your variable correctly, it does need the // at the start of it. We can see that my panel on the right and the panel or background of project 1's container shows whatever our camera is seeing. So now inside, I could click my camera and it's by default moved 5 units back on the Z-axis. I could change that to be 10, and now we can see that my cube is smaller, simply because the camera's further away. Or I could move it closer and even go through it. So if we look at the 3D, my camera's now past it. It doesn't see the cube because the cube is behind its view. So this is why it's useful to have both the 3D view and our panel 2D output of that view at the same time. But for now, I'm happy with it being at 5 units back on the Z. Okay, so we've got a box into a null, into a geo. So we take a shape and turn it into a geometry that is in our 3D world. We've then added a camera and a light to look at that geometry and turn it into a render. So we turn a 3D shape into a shape in the world. We look at it with a camera and a light, and then we put it all into a render, and we can see it automatically gathered everything. And that render is now showing us what our camera and light are illuminating and seeing. By default, all our shapes are gray and fairly boring. So what I'm going to do is I'm going to double click and I'm going to add a constant top. And if you can't find it, you can click the search bar and type constant. And you can see that Touchdesigner unilluminates the rest of them and shows me all the operators that have con or con in the start of it. So I can do a convolve or a constant. I'm going to add a constant, and a constant top is a way for us to make a pure color. By default, it shows us white, but I'm going to click the color box, so that white square, and I'm going to set it to any color that you want. Mine is going to be a weird pinky purple. I then want to take this color and apply it to my geometry. so it shows as the color of my geometry. Now, I alluded to this when I first did an overview of Touchdesigner, but I can't go straight from a texture that is a top onto a 3D shape. I need to go via something called a matte, which is a material. So I'm going to double click and I'm going to go to the mattes tab, and we can see there's way less of these than any of the other types of data. And I'm going to add a Fong. I'm also going to double click and I'm going to add a constant directly below it. So now I have a Fong matte and a constant matte. I can now pick up this whole operator, and I don't need to do like we did with the chop in the first reference example and activate the viewer and drag and drop it, because there is only one value here. So I can pick up my whole texture operator, my whole constant, and drag it onto my Fong. And I can see I get a load of values I can link it to. I want to choose color map. And that's going to say, take the color of this constant and apply it to be the color of your Fong. The constant doesn't give us any choices, it just links it to be the color. That's because a Fong is a more complicated texture than a constant. A constant, if you pick up the constant matte and drag it onto your geo and pick material, so that's pick it up, drag it on and click material, you can see our cube has now gone a perfectly illuminated version of our color. We can no longer see edges or depth. If I was to click my geo and rotate it on the Y and on the Z, and on the X, sorry, you can see that there, even though if I move my mouse down here, there is a corner, I have no definition of it like I do in my viewer. And that's because a constant material applies the color without accepting light anymore. So every single side and pixel in this shape is fully illuminating the same level of color. There's no light, there's no depth. It is no longer effectively a 3D shape. The Fong, however, maintains that 3D aspect. So if we pick up the Fong and apply it into the material of our geo, we can see that we get one face is more illuminated than the others, and that's because our light is facing onto that one directly. I could click my light and I could move it on the X or Y, and you can see I can change how light hits the surface. So in a 3D space, a constant material is really good if we need to always see something, and it does have its uses if you want to make special or certain effects, whereas a Fong allows us to have a 3D shape that interacts with light in our 3D world. It's a much more realistic version of what we would actually see if we were to view it in the real world. So I'm going to leave my Fong connected, but I'm going to leave my constant there just to remind me that there are two other mattes, or there are other types of materials I can apply to get different effects. The original goal is we're trying to make a background that is something that we can use as the backdrop for our scene. So what I'm going to do is I'm going to come to where my box is, and I'm going to double click, go to the SOP page, and I'm going to add a rectangle. And I'm going to drag and drop the end of my rectangle over the top of my box's chain. You can see it goes yellow, and I can let go and I can snap and replace. And what that has just done is it replaced our box with a flat rectangle 3D shape. I'm going to reset my geometry back to default, so I'm going to 0, 0 the rotation inside the geo. And now what I want to do is I want to add a transform between my null and my rectangle shape, just so I can spread it to fill the width of my camera. So I'm going to right click when the connector is orange, connector is yellow, insert operator, and insert a transform. And I want to make the scale wider until it fills my view. So I can see I scroll that up and it's about 4.5 will be enough. And I also want to scale it up in the Y so it fills my view to about 2.4. Now scaling the Z does nothing because this is a perfectly flat shape. It has no Z depth. It is 0 wide on the Z depth, unlike the box that did have a shape. So if I plug that in, my box almost does the exact same thing, but now I could make it deeper or skinnier, but we don't want to have to deal with that, so I'm going to set it back to 0 and I'm going to set Z depth back to 1. So now I have a rectangle that is on 0, 0, 0, that is 4.5% X scaled, and 2.4% Y scaled. So it fits this rectangle shape, and most importantly, fits my viewer. Now, this is one of the examples where I would use a constant. Because this is a shape that I'm just using as a backdrop to my 3D scene, I don't want it to accept light the same way that a shape in front of it should. So I'm going to drag and drop the constant onto the material for my geo, and now I get this nice flat color purple, rather than the thong that was being influenced by my light at 10 units away. So if I flick it back, you can see it gets a slightly brighter spot in the middle and then ramps out. Constant is as if 100% light is hitting 100% of the surface. So with that in place, I'm fairly disappointed with the color purple over all of it. So I'm going to double click and go to the tops page, and I'm going to add a ramp. And the ramp by name generates a gradient of lots of different types. So it's horizontal, you can do a vertical, you have a radial, or a circular. So we can do lots of different patterns on this screen. And if I pick my ramp and place it onto my constant, what you'll see is it snaps, and now we have this color pattern that matches the ramp spread over the surface. And because we now have a non-square surface, because we just stretched it to be rectangular, it gets this little bit of warping on it. But that's fine, because I'm actually going to change it to be horizontal. And I'm going to click where the little black peg is, and I'm going to change this to be a color. So I'm going to pick a color, like green on the hue, turn up the value, and then turn up the saturation, so I get the color that I want. And then I'm going to pick anywhere on the line and slide down, just so I create a slightly harsher color transition. Doesn't matter what yours look like, just follow along with the theory. So now I've got that. My background still isn't doing much, but we can control something like the phase and the period, so how many offer items are there, to create an exciting effect. And by exciting, I just mean any effect more than static. The image not moving. So what I want to do is I want to introduce data from a chop that allows us to drive this background to do something a bit more exciting than just staying still. So the first thing I'm going to do is I'm going to go to the chop menu, and a really good way to make data is by using an LFO, a low frequency oscillator, something that goes from being 1 to -1. We can change the type of the wave that this generates, and I'm going to change mine to be a ramp. And a ramp goes from being 0 to 1 on the frequency that we've set. When it has a frequency of 1, it means it runs at the same frames per second as Touchdesigner. So over a frequency of 1, it will change from 0 to 1 over 60 frames. I can change it to be 0.5, and it now means it's going to take 2 seconds or 120 frames to do the same animation. I'm going to add that LFO that is a ramp to a null. I'm going to activate that null, select my ramp, and drag and drop the value into the phase. So just like we did in the first video, I'm going to activate the viewer, highlight the value when it's green, and drag it and drop it onto the value. Select relative chop reference of my ramp. Now I have a background that is moving, and we can see it both in 3D and in our 2D representation of what our camera is seeing. Okay, I'm also going to turn the phase down slightly so that we get this sort of quick repeating pattern. And it kind of just makes a slightly more exciting background. So we have taken a 3D shape, turned it into the real world, or Touchdesigner's global world. We're looking at it through a camera, and now we have added a ramp to the background and animated it using data from a chop. But I feel like we can do slightly more in the context of our background here. It has no depth, it's very flat. So what I'm going to do is I'm going to use a special technique called instancing to liven up our scene slightly. So at the moment we have one rectangle that goes into a transform, that goes into a null, that goes into our geometry. I'm going to make my rectangle super skinny, and I'm going to turn it back to being a constant color. So now I have one rectangle that's floating in space. So it's 0.1 on the scale and 2.4 tall, so it still extends the full length, but now it's sitting in the middle. And if I was to move my geometry left or right, we can see that I can move it in 3D and I can move it in my screen. But we can use other pieces of geometry to tell Touchdesigner where to put these up and down spikes in our viewer. So I'm going to double click and I'm going to add a line. Now, a line by default is exactly what it says on the tin. It is a non-visible 3D shape that is a pixel wide that is just a line. You use it for like creating paths and other things. If I add this to a null, and then I'm going to pick those special blue and purple dots. And in our scene, if I home select it, we can now see that our line is drawing from 0 out to 1. But I want this to go from about, I can actually see it in my camera here, I want it to extend the full length of my screen. So I'm going to change point A's x value to be negative 2.2. And because it's a perfect mirror, I'm going to change its B point to be positive 2.2. We can now see in this little viewer, if I go full screen, that it extends the full length of my screen. And it has 2 points in it. I'm going to change the number of points it has to be about 15. And now if I come in on this viewer, activate it, you don't need to worry about following this bit along, it's just for demonstration. I'm going to right click and do display options and do points. Now we can see that instead of this line having just 2, one at the start and one at the end, when I increase it to 15 points, it gives me an evenly spread 15 points across its length. I can now use this parameter to control how many of these spikes that we see using something called instancing. So I'm going to click on my geometry. Oh, I just pressed something by mistake. I'm going to click on my geometry. I'm going to go to its instancing tab and I'm going to enable it. And we can see that our spike suddenly disappears because we've not told it to make an instance of anything. I'm going to drag and drop all of my null coming out of my line into the instance parameter up here. And now we see one version of our spike by default. When we instance, I can use the location of all these points in 3D space, so they all have an X, a Y, and a Z, on that line that we were visualizing. I can use them to tell Touchdesigner to draw a new version of our spike using that information. So what I can do is, where it says TX, I'm going to click this arrow at the end and link it to P0. On TY, I'm going to click P1. And on TZ, I'm going to click P2. Now we can see I have 15 lines all in a row on our screen. And due to the way that our camera is set up, we actually only see 2, 4, 6, 8, 10, 12, 13. So we're missing the leftmost and rightmost line, but for now it doesn't matter. What it's doing is it's taking the reference geometry we have here, which is our line with 15 points, and it's creating one version of the geometry we have going into it using the inlet we created on each of those points. So it's taking this geometry we've made and placing an instance or a copy of that geometry on each of these points up here. This is the same as us having an array of like your alien object or a character inside processing that we then would use a for loop to run on and be like for I in range whatever. Touchdesigner is just doing this all in a visual method for us. Now I want to completely fill my screen, so I'm going to make more lines, and I'm going to do that by increasing the number of points. So I'm going to go to 20. I'm actually going to keep going until all my lines appear to touch each other. So there we go, between 44 and 45 for me, depending on what I did. Now makes it look like I have a perfectly flat surface. But the important thing to remember is I don't. I actually have 45 versions of my spike. And I can give each of those spikes a different color because it's instanced. So I'm going to come down to where I have my LFO and my ramp, and I'm going to make some room. And I'm going to double click and I'm going to make a noise top. A noise top is another really good way of making content rather than manipulating it. So noise uses a bunch of 3D algorithms to make noise for us that is completely random in shape depending on all these values in here. I want to untick the monochrome so it appears as color. And then I'm going to use a special trick to make this a single row of 45 different random colors. And to do that, I'm going to come to the common page. I'm then going to change its resolution from being 256 to 256 to be the number of pixels that we want. So I'm going to say 45 by 1. So I have a row of 45 colors that blend into each other, generated by this noise. Now, I don't like the way that these aren't solid colors, and because I have 45 different pegs, I want 45 super defined colors. So I'm going to say in the viewer smoothness, instead of interpolate pixels, I'm going to say nearest pixel. And that's going to suddenly snap this so that I have all these different colors really strongly shown here. And then we're going to use our first actual piece of programming here, as you would notice, or as you would be used to inside processing. So I'm going to click the transform tab, and I'm going to, where it says transform Z, or translate, I'm going to click the box down. And in TZ, for the Z parameter, I'm going to type ABS, capital T time, dot frame, enter. And what that's going to do is it's going to reference the time that Touchdesigner has been running and get how many frames it has rendered since it started. You can see here, this is rendered 86,000, almost 87,000 frames. But it does make our image strobe a little bit. So I'm going to slow it down. So I'm going to divide that by about 1,000. And what that will do is it's now, imagine we had an infinitely long sample of colors. It's now going to slowly move this image through that random sample of colors. So we can see very slowly all of these will fade in and fade out and change color. And we did that with a Python reference to the time that Touchdesigner has been running. But if I apply this to the constant, we get this really weird effect, because using the method that we did to generate the background means that all 45 of our spikes now have the full 45 colors. You can see that by this almost repeating ramp style. So we can use the power of instancing and a different way of assigning color. If we look at the instancing tab 2 of our geo, it has something called color mode. And we can use that to control the color that we see on our shape. We just need to get the data from here into here. So I'm going to delete my Phong and my constant so that my shape goes back to basic gray. And I'm going to move my noise up near where my line is. Now, one of the first rules I told you about Touchdesigner is you can't connect purple to blue, and I can't connect blue to purple. So for me to get my color data into this null 3, that is currently where the instancing data is coming from, I'm going to need to do some data manipulation. So the first thing I'm going to do is I'm going to change my data types into something that's much easier to work with. And for that, I'm going to use DAP. So I'm going to double click a blank space and insert a DAT2, or a SOP2. And this allows me to transfer between these two data types. Now if I drag the blue onto the pink, we can see it fills with index P0, P1, P2, and something called PW. And if you have it enabled, it will also show you something called N0 through 1, or a 0 through 2, which stands for the normals. But what we're essentially looking at is a text version of all this data here. P0 being the X location, P1 being the Y location, and PZ being the P2 being the Z location. So we can see that all of our points aren't moving in the Z depth, and they aren't moving in the Y depth, but they are moving in the X depth, this red line. So the only number that changes in all these rows is the X number. So this here, I'm going to add that to a null. And then instead of referencing my SOP null, I'm going to drag my null, dat null, and copy it into param instance chop.sop. Nothing will change because we're using the same data to get the instancing location. We're just doing it in a slightly different way. In this case, we're using dats rather than sops. But it's much easier for us now to go from top into dat than it is for us to ever go from top into sop, which isn't actually possible. So I'm going to right click my noise, and I'm going to go to the chop page, and I'm going to bring in a top 2. So now I've gone from top into chop data, and we can see all those color values changing in a long form. And now I can right click and go from chop into dat with a chop 2. And I'm going to make sure to click include names. So now I've taken my texture data into channel data, and that channel data into normal text data. So now I have an equal number of rows. This has, if I middle click it with my mouse, it says it's got 46 rows. My color data also has 46 rows, and that's why we set it to a really specific resolution. I want to merge this chop2 with my sop2. So I'm going to insert a merge, and I'm going to drag and drop this into here. Now this is going to do really weird things because it's doing something called appending rows, but we want to append columns. Everything will visually look the same, but now if I go into my instance 2 panel, I can see that instead of just P0, P1, and P2, I now have R, G, B, and A, which means that all of my spikes get a very unique color as made by the random up here, or the noise generator up here. And you can see this visual representation here is almost, well, it is identical to the colors that we see represented on the spikes there. But we now have 45 unique colors on 45 unique copies of our spike. And this is the power of instancing. It means that we can have a version of our original geometry, but do anything we want to it. We can change its scale. If you look at this, we can change its rotation, we can change its scale, we can change it, what's called its pivot point. We can change which way it faces up. We can also change how it applies textures to its surface. And we've already done color. So as well as color, we're going to change the way that these position themselves. If I change my merge back to append rows, you can see that we almost get these versions that come out in front of us and move around a little. I really like that effect, and I want to create that so that all of my shapes are now moving around freely in this viewer space. So I'm going to change that back to append columns. How do I move my shapes? Well, we're already positioning them in space based on the P0, P1, and P2, or the X, the Y, and the Z location of our line. So I can use some randomly generated values, like noise, in chop format, to move them around in space by adding the original value to a value that I randomly create. So I'm going to double click, and I'm going to place a noise chop. Now the noise chop by default is 10 seconds worth of samples. We know that there's 60 samples per second, so this has 600 samples. And we don't need that much. We only need 45 because we have 45 columns. So in the channel parameters page, first thing I'm going to do is I'm going to make 3 new channel names. So I'm going to delete channel 1, and I'm going to do X space Y space Z. And that makes 3 different random numbers. And in range end, I'm going to type the number I want to get, which is 45. I'm going to divide it by the current sample rate, that is 60, and I'm going to push enter. And that's just a really quick maths way of getting the right number of samples based on what we want. So Touchdesigner runs at 60 frames per second, as shown at the top and in the bottom left. I only need 45, so I'm going to divide 45 by a sample rate of 60. Again, don't worry too much if that just sounds crazy and like I'm talking rubbish. If you ever come to PlayLab and learn classes with me, we understand what all these things mean and why we would ever use them. But for now, know that we've made 3 random values that have 45 different random numbers over time. So I have 45 different random z's, 45 different random y's, and 45 different random x's. I'm going to do the same trick we did with our random color, and I'm going to translate this in the x by abs time.frame divided by 1000. And all that means is that our random numbers are ever so slowly going to change over time. You could even reduce that 1000 to 100 if you wanted to see it changing more rapidly. Okay, so now I've got my noise. I'm going to right click and go to a math that I'm not going to do anything with just now. It's just adding to my pipeline just in case I need to change how far objects move. I'm then going to add a null. And to that null, again, I'm going to do that trick that does the chop to dat. So I'm going to double click, add a chop to, and drag my green null onto the pink dat. I'm going to include names, and I'm going to place it into our merge. Now I could click on our geometry, and I could change P0 to be X, Y, and Z, which means that all of our spikes are now moving based on the random numbers being generated by our noise. I could use the maths range to change how they are drawing, so like from 0 to 2 to -2 to 2. And in our 3D viewer, we can see that they're all over the place, spreading out, but we're starting to lose them in our visual viewer. And that's because they've lost that reference to the line that we originally had. So I'm going to go back into my geometry and set these back to P1, P0, P1, and P2. And I'm going to delete the connection from the merge. So I'm going to go to my chop to 2, right click and delete. And what I want to do is I actually want to add these to the original values coming from our SOP. This is much easier to do in chop form than it is dat form. So I'm going to move this SOP2, or I'm actually just going to delete this SOP2 for now and not worry about our missing image. I'm going to right click my SOP and introduce a SOP2 chop. So same way that we went from the SOP data to that dat pink, we can now go from the blue to the green. And you can see I have 45 channels, X, T, Y, and TZ. I want to then look at my noise, which I've said can have a maximum of -2 or 2. And I'm going to make that -1 or 1 in the range tab. So now I'm letting the noise move our spike between 1 and -1 from its original position. I'm then going to add another math and go from my SOP2 to my null5. And I'm going to say combine chops by add. And that means it's going to recognize I have 3 in one and 3 in another and add them both together. So where 1 was originally 10 or 2, it now goes all the way up to being a positive, offset by the value of our math, hopefully. I now can take this math into that chop 2 and that chop 2 into our merge. My channels are no longer called P0, P1, and P2. However, they're now called TX, TY, and TZ, just due to the way that values change names as we connect them to different data types. So in the geometry, I'm going to enable TX, TY, and TZ. And -2 is looking like it's way too much. We may not even want to change them on the Z at all because they're slightly too deep. So in our math, I'm going to change that range to be, I'm going to change my range to be 0, which means that so it's from range, the math is basically doing nothing here. We're just taking the raw values from the noise. Okay, so now that's done, we want to make it a wee bit more intense on the movement. So I'm not really liking the massive amount of difference it's getting on the Y, which is up and down here, and the lack of apparent movement on the Z. And I think that's just because we have 45 panels. So I'm actually going to go back to my original line, and change its number of points to be double the normal I would expect. So I'm going to set that to 90. And you can see that we get a bunch of black lines appearing, half to be exact. And that's because our texture, or our panel of colors, only generates 45. So I'm going to make a slightly more programmatic link so that this does it normally. I'm going to write a piece of code that goes into line 1, gets the number of points it currently has, and uses that to set its resolution. So to do that, I'm going to type in Python using Touchdesigner terms. So it's going to feel like the work you had been doing in processing, but it has a specific meaning in the code we're doing here. I'm going to type operator, open parentheses, open single speech, line 1, close speech, close parentheses. And that is just Touchdesigner Python code to say go and get this operator's values. I then need to tell it which parameter I want to get, which click on this, I want to get the number of points, which has the value name of points. So I'm going to say operator line 1 dot par dot points. And we can see that automatically it's going to get the number of points that we set in there thanks to the parameter value, and it's going to set this to be 90 colors rather than 45. And I want to do the same with my noise generation. So I hand typed 45, but again I can type operator parentheses line 1 parentheses dot par dot points. And we can see it now gives us a value time of 1.5, because that's 90 divided by 60, which is 1.5, and we have 1 to 90 channels. So that reference of operator name dot par dot points means go to the operator called line 1, get its parameter, this is the parameter window, remember, called points, and get whatever that is set to, which is currently 90. I could set this to 10, and we could see that it can automatically update both of these to be the right amount. So why am I setting it to 90? The reason I'm setting it to 90 is because I want to have double the depth of data. And I'm actually going to change my noise so it only has Z and X movement. So I only want to move them forward and left and right. So I'm going to delete Y altogether. So my noise updates, and now it's X and Y. Okay, with that done, I also want to make my noise way more random. So I want to change the type of random generation, because we're getting kind of a wave being drawn, whereas I want them to be all over the place. So I'm going to come to the noise tab, and I'm going to change the roughness way up. We might even need to change the type of noise we're making. So I set my roughness to be around 0.5 still is probably fine. And then I turned my period way down. And that means that it increases how aggressive our random noise maker is. And that gives us a much more jagged appeal. I want them to move slightly faster. So I'm going to go to the transform tab and change my value to be from divided by 1000 to divided by about 100. And now you can see we get this real warping movement where all of our lines are moving in front of each other on different values. The one problem we do have though is our math is taking a combined value. When we try and add 3 and 2 channels together, Touchdesigner gets a bit confused about what we're trying to do. So you can see here that they're still moving up and down when all I want them to do is move forward and left and right. So I'm going to have a look at my chop, and I'm going to say by channel name, which means that this one will stop adding and it'll look normal. And instead of X and Y, in the channel names of my noise, I'm going to change that to TX and TZ. And now that means that our TY stays exactly as it originally was, because in our math, we said match by channel name, which means Touchdesigner is specifically looking for a channel called TX to match with a channel called TX. And if they find them, then it'll add them together. Now we're starting to get the effect that I was looking for, where in our viewer down here, we can see that we're getting this sort of moving value. And then if we look at them in actual 3D, they're moving in front of and behind each other. Let's make it a bit more aggressive by changing the amplitude of our noise. So I'm going to change that to about 2.5, which means that the noise's maximum peaks can be between negative 2.5 and positive 2.5. And with a roughness of 0.5, it means that our values will range nicely for us. And we get these spikes coming closer to the camera and spikes further away from the camera, all the time moving in front of and behind each other. Now, I want to make these a bit more fancy. So where we have our color, I'm actually going to select all of this and move up slightly. I want to extract the A value from our color and make them fade in and out of existence as well, so that we can see the ones behind each other. So what I'm going to do is I'm going to make a new noise, and I'm going to call its channel A for alpha. I am going to make it a sparse with an amplitude of 1, and then I'm going to add that to a math, and I'm going to say channel post operation positive. And that means that all our values always have to be between 1 and 0. I'm then going to add another transform, and this time I'm going to say abs time.seconds rather than frames. And that'll give us the number of seconds Touchdesigner has been running rather than the number of frames since it started. And you can see it's been running for 6,600 seconds, so it's been running for a few hours now while I've been recording these videos. I am going to probably slow down the transformation of my movement one more variable, so I'm going to change this to be something like 500 rather than 1,000 so that they move nicely. And now I need to add this A to this A. So I'm going to add a null here, a null chop, and connect that null chop to the chop 2 instead. So my pipeline has changed. And in between, as we did up here, I want to add a math. And so I'm going to insert math. And then I'm going to connect my alpha, noise. I'm going to combine chops by adding them, and I'm going to match by channel name. So my alpha has now taken on the value of my noise. The one thing that's causing an issue here is that my noise is slightly too long. So I'm going to use that same constraint of operator, line1, dot par, dot points, divided by 60 in the noise channels end range. So now I have my warping colors, adding a warping alpha value. It's not spiky enough, so I'm going to change the period down quite a bit. Slow down my time slightly, so divided by 100. There we go, so it should morph over time. I'm going to have a look at my geometry, make sure it's got its A value in there. So I'm just having a look. All the alpha values are originally 1, so I want to just replace. So I don't want to add. Okay, so what I did there is I changed the math, combining my two A's together to be subtract chops rather than add. Because the problem we're getting is our alpha, which goes between 0 and 1 for invisible to fully seeable, was scaling from the original alpha, which was 1 for all of our devices. So they were all on. Now they are actually rolling in front of each other. It's just kind of hard for our camera to see for two reasons. One, the colors, the way that they're blending is very hard to see. And the second is our spikes don't have a texture on them that tells them that they can blend between each other. So we're finished with that. I'm going to say that we're finished with our background and we can leave that at the top. The last thing I want to do is I want to come down to where our rectangle is going into our geometry, where all the instancing is happening. And I'm going to right click between the transform and the null. I'm going to insert a a material SOP. And with that, it means that I can apply a style of material that the surface should take without giving it a color. I'm then going to double click, add a constant, and drag it onto the material. So what you should see is all of your spikes now take on a more candied colored sort of format. And that's because they're now no longer taking light from our camera render scene, but just purely being 100% of the color they're meant to be. In a constant material, on the Common tab, there's something called blending at the very top. We want to enable that. And what that means is our spikes are now able to flow in front of each other and behind each other correctly. And it might be a bit hard to see, but you could turn down the amount of points that you have if you want to see it clearer, where one spike can very clearly cross in front of another spike, as we can see happening here, where the colors start to blend to different forms. We can see there's a really good example. If you want to increase that, what you could do is, if you were to change the amplitude of your noise slightly, the alpha values of your colors will increase, or decrease I should say, which means that it's easier to see colors or spikes overlapping each other. But it also means that they're all slightly dimmer, which is just a price that you need to pay. So play about with the amplitude of the noise in your alpha to get something that you like the look of. So I'm going to stick with mine at about 1.9 because I like the super transparent look that I can get on some of them, and then the strong colors on top of each other. I might come up to my noise for my TX and my TZ and change the amplitude of that as well, just so they get slightly more spread out. And we get this really nice effect of lots of spikes moving in front of each other that have different colors that are fading and in and out of existence, all randomly. And I think I'm happy with that there as my background. So it's super dynamic. Every time I run the program, it's going to be different. And it means that I can just leave it and run, and I know that I'm going to get this dynamic experience. So I'm going to save my project and end there. And in the next video section, we will look at adding the responsive audio experience in front of that background with a single shape that pulses and changes size based on what it's hearing.